Good evening, friends. After the discussion of reflection of a wave from the rigid support from the free end. Now the next topic is what is the stationary wave? When the two waves are superposed at any point in the medium, both having the same amplitude, same frequency, right? And both are traveling in opposite direction. At that time what's happened? The stationary pattern is formed in the medium. That means the stationary waves are generated. Then this pattern loses the property of propagation. Such pattern is known as the stationary wave. Right? First, the question is that define the stationary wave and obtain its equation. Right? So what is the definition? When the two waves of the same amplitude, same time period, same frequency and same wavelength are traveling in opposite direction and superposed, the resultant wave format is known as the stationary wave. So the definition of stationary wave is that when two waves of same amplitude, same time period, same wavelength or the same frequency and same wavelength moving in opposite direction are superposed The resultant wave format is called stationary wave. Again, when the two waves of the same amplitude, same time period, same frequency and same wavelength moving in opposite direction are superposed, the resultant wave format is known as the stationary wave. Now the another definition is when two waves of same amplitude and same frequency, same amplitude and same frequency moving in opposite direction or the traveling in opposite direction are superposed. The resultant wave formed in the medium. The resultant wave formed in the medium loses the property of moving or the property of propagation. Loss is the property of propagation. Such stationary pattern and such stationary pattern is known as the stationary wave. And stationary pattern is formed is known as a stationary wave. Again, the another definition: when the two waves of the same amplitude and same frequency moving in opposite direction are superposed, the resultant wave formed in the medium loses the property of propagation, and the stationary pattern is formed. This stationary pattern is known as the stationary wave. Like this way, the two waves are propagating in the same medium, having the same amplitude, like this way. There is the one wave. Now the second wave is, this wave is propagating in positive x direction. Now the second wave is propagating in negative x direction, like this manner, having the same amplitude and same frequency are superposed. So this pattern that is traveling in negative x direction. Amplitude are same, frequency are same. So this type of the stationary pattern is formed. This stationary pattern loses the property of propagation. So this wave is known as the stationary wave. That is the wave 1 and that is the wave 2. Right? Again the definition: when the two waves of the same amplitude, same frequency, same time period and same angular frequency and same wavelength moving in opposite direction are superposed, the resultant wave formed is known as the stationary wave. Instead of this definition is clear. When the two waves of the same amplitude and same frequency moving in opposite direction are superposed, the resultant wave formed in the medium. This resultant wave loses the property of propagation and stationary pattern is formed. This type of the stationary pattern is formed. Is known as the stationary wave. Right? Consider the incident wave propagating in positive x direction. Consider the incident wave propagating or the moving in positive x direction. Moving in positive x direction is y1 xt is equal to a sine kx minus omega t. That is the equation 1. And the reflected wave or the other wave moving in minus x direction minus x direction is y2 xt is equal to same amplitude, same wave vector and same angular frequency. But here there is propagating in negative x direction, therefore positive here. There is propagating in positive x direction, therefore negative sign here. From principle of superposition, from principle of superposition the resultant displacement yxt is equal to y1 xt plus y2 xt. We substitute the value of equation 1 and 2 in this equation. Therefore, yxt is equal to y1 xt a sine kx minus omega t plus here y2 a sine kx plus omega t. A is taken common into bracket here sine kx minus omega t plus sine kx plus omega t. Here we apply the equation of trigonometric function sin c plus sin d is equal to 2 sin c plus d by 2 and cos c plus c minus d by 2. So here we are applying this equation sin c plus sin d is equal to 2 sin c plus d by 2 into cos c minus d by 2. Therefore, our equation becomes the resultant displacement yxt is equal to a here 2 these two of our equation. Now into bracket sin c plus d by 2 kx minus omega t plus kx plus omega t by 2 into cos c minus d kx minus omega t minus kx right and minus omega t by 2 minus omega t by 2. Therefore, here kx cancel, here the omega t cancel. Therefore, 2a, here sine, here 2kx by 2, that means the kx into here cos minus 2 omega t by 2, 2 cancel, therefore minus omega t. But we know that cos minus theta is equal to cos theta. Therefore, we obtain 2a sin kx cos omega t. That is the resultant displacement of the two wells superposed at any point of the medium. Right? 2a sin kx into cos omega t. Now, there is the general equation of equation number 3. Equation 3 is the general equation of a stationary wave. A stationary wave. Now listen here. The amplitude of the stationary wave is 2a sin kx. The amplitude of a stationary wave is, this term is the amplitude. There is the 2a sin kx. Right? And at the different point are the oscillating with the different amplitude. The amplitude of the stationary wave is 2a sin kx. The different points are oscillating with different amplitude. With different amplitude. Because in the pattern, here these are the points of the medium. At this point, the amplitude is maximum. This point, the amplitude is quite less. Here the amplitude is 0. According to this equation, y is equal to 2a sine kx. Yes, we substitute the different value of x. We obtain the amplitude of different particles of the medium, which are under the superpositioning of the two waves having the same frequency and same amplitude. Right? Kx and omega t are the different. Right? And therefore, the stationary form is not a function of f into kx minus omega t. Thus, a stationary wave is not a function f kx minus omega t. Is not a function of kx minus omega t, and hence they are not progressive wave. Thus, it is not a progressive wave. There is a stationary wave. So there is the equation of the stationary wave, very easy, only the mathematical terms and definition of the stationary wave. Again we repeat, what is the definition of the stationary wave? Now, when the two waves of the same amplitude, same time period and frequency, and also the same wavelength, moving in opposite direction are supposed, the resultant pattern or the resultant wave format is known as the stationary wave. Two waves with the same amplitude, same time period, same frequency, and same and also the same wavelength moving in opposite direction are supposed. The resultant wave format is known as the stationary wave. Another definition is that when two waves of the same amplitude and same frequency moving in opposite direction are superposed, the resultant wave format in the medium loses the property of propagation, and stationary pattern is format is known as the stationary wave. So due to the superposition of the two waves moving in mutually opposite direction, whatever the resultant pattern is format, that is the stationary, not moving either in left or the right side. So this type of the waves are generated in the string tied with the both rigid support. Right, like with this way. Yes, we produce the disturbance. So what's happened? The waves are propagated in this direction. These waves are returned back or they reflect at the both ends. So this type of the stationary waves are produced in a string tied with the both rigid support. Now, to obtain the equation of the stationary wave, here we have to consider the two waves propagating or the moving in opposite direction. So one wave is incident wave and second is the reflected wave. Therefore, consider the incident wave moving in positive x direction is y1 xt is equal to a sine kx minus omega t. That is our equation 1. This wave is incident on the rigid support and reflect back. Therefore, the same wave is generated, the traveling in opposite direction. Right? So the reflected wave moving in minus x direction. Therefore, y2 xt is equal to a sine kx plus omega t. Here this wave is traveling in minus x direction. Therefore, here the sign is positive. Here this wave is propagating or the moving in positive x direction. So here the sign is negative. So here both waves are superposed at any point in the medium. Therefore, from principle of superposition, the resultant displacement y is vector sum of displacement of individual wave. Here we substitute the value of y1 and y2. Therefore, resultant displacement by xt is equal to a sine kx minus omega t plus a sine kx plus omega t. A is common. Sine kx minus omega t plus sine kx plus omega t. This equation is similar to this sine c plus sine d. 2 sine c plus d by 2 into cos c minus d by 2. So this 2 is taken here. Therefore 2a outside of the bracket here sine c plus d by 2 kx minus omega t plus kx plus omega t by 2. Now cos c minus d by 2 c kx minus omega t minus d, that means the minus kx minus omega t by 2. Now here first bracket omega t cancel, therefore 2 kx by 2 to cancel only kx. Second bracket here the kx cancel minus 2 omega t by 2 to cancel only minus omega t. Therefore the displacement of resultant wave y is equal to 2a sine kx into cos minus omega t. But we know that cos minus theta is equal to plus cos theta. Therefore, 2a sine kx cos omega t. Clear this? Okay. Now, equation 3 is the general equation of a stationary wave. The amplitude of this stationary wave is represented by the equation 2a sine kx. 2a sine kx. The different points are oscillate with the different amplitude. So here the different points of the medium in stationary wave are oscillate about their mean position with the different amplitude according to this equation 2a sine kx. And the frequency of this oscillation is this omega t, or the omega. Omega is the angular frequency of oscillation of this particle of the medium at which the stationary wave is formed. As we substitute the different value of the points, so we obtain the amplitude of a particular point. The some point has the maximum amplitude, while some point has the minimum amplitude. So these points at which the amplitude of the particle becomes the zero are known as the node points. And the point at which the amplitude of the particle of the medium is maximum, these are known as the anti-node points. We discuss later. Right? Now, the amplitude of the stationary wave is 2a sine kx. 2a sine kx. By substituting the different value of x, we can find out the amplitude of the different points. Because the different points of the medium oscillating with the different amplitude. Thus, the stationary wave is not a function f kx minus omega t. Thus, it is a progressive wave. It is not a progressive wave. That is the stationary wave. Here the initial phase phi is equal to 0. Therefore, here also the phase is 0. Clear this? So that is about the stationary wave and equation of the stationary